Hi, I'm Ray Conover, and I'm here at JTEG. Today I'm going to talk to you about magnetism and electromagnetism. First I'm going to start with magnetism. You have a basic magnet with a north pole and a south pole. And what happens is each magnet has a magnetic field that flows from south to north and back to south. So it comes out the top, flows around on both sides. The stronger the magnet, the stronger the magnetic field. The farther it flows out. The closer you have a piece of metal to the magnet, the stronger the magnetic field. So this area right here and this area right here will be the absolute strongest, each one. And the poles will be the strongest too. But always remember, what happens is when an item is magnetized and becomes a magnet, the molecules inside are all aligned from south to north. So your flux lines, magnetic flux lines, that's these right here, always flow from south to north, out, and back to the south, and back to the south. So I just talked about magnetism. Now I'm going to talk about electromagnetism. And electromagnetism is when you induce electricity through a wire. It creates an actual magnetic field. And I'm going to show you that by creating a very small electromagnet. You need a power source, something made of steel like this bolt, and a coil of wire. Alright, we all know that this isn't magnetic. Put the bolt through the wire, attach it to your power, and then it becomes a magnet. Now to make this stronger, I would get either more steel, more coils of wire, or more power. Now also, if I stripped the shielding off of this copper wire, the field would be a lot stronger. Basically what happens here is the electrons flow through and the magnetic field is amplified because they start to spool through the coils of wire, creating your magnetic field. In turn, turning the steel in this bolt magnetic by aligning all the poles of the molecules in the way that the electrons are flowing. 1.62 billion electrons flow over 1 inch of wire per second. Or excuse me, 1 millimeter of wire per second. Okay, talking about electromagnetism, I'm talking about how it's used in relays in automobiles, relays and switches. Basically what happens is power is applied through the coil of wire to ground. Now your switch can be open or closed depending on what kind of switch or relay it is. If it's closed, when the magnetic field is induced around the coil, it's going to pull a thin sheet of metal between these two poles and open the circuit. Now let's say it's a open one. When you remove the power, switch will close. Okay, still talking about electromagnetism. I've built here a very small electric homopolar motor. Basically what you have is a very strong magnet on the bottom. You have a battery and a coil of wire. Now what's happening here is the electrons are flowing from the positive side of the battery through the wire, down the coil. The electrons want to move to the negative side of the battery but can't because the magnet's in the way. So they're jumping through the magnet, jumping to the magnetic field and actually pushing the wire. And that's why the wire spins. And this is the very basic way an electric car motor works. Without this, we wouldn't have electric car motors. And that's it. And that's Ray dropping some science on your ass.